video, we have discussed the principle of original horizontality. So normally, rock layers would follow a conformity, that sediments would always form a horizontal layer. But unfortunately, that's not always the case. Although originally they will form the horizontal layer, eventually, because of tectonic processes, they may be pushed in another direction or another orientation. So, for example, here in this picture, you may see like a normal, quite amazing rock layer, but if you know your earth science, it will tell you a lot of things. So looking at this picture right here will show you what a geologist see. You will see that you have rock layers here that does not follow anymore the principle of original horizontality. It did when it was forming, but now it's just not horizontal anymore. You have a Ordovician sandstone and shale, which is vertical, like completely vertical. So if you can imagine, from being horizontal, it is now pushed and became vertical. And then on top of that, so if you remember, Cambrian, Ordovician, Silurian, Devonian. So it means, so during the Ordovician period, this rock layer was formed horizontal, but between the Ordovician time period, Silurian, for some reason during that period of time, it became vertical. And then by the time of the Devonian, another sandstone layer was formed. So it's possible that it's not as slanted or not as vertical before, because the Devonian is now diagonal, but it used to be horizontal. So it would give you some sort of mystery, like this layers of rock would give you some more history and mystery at the same time. Right. So we have discussed conformities. Now we will be discussing unconformities. So what you see here is a type of unconformity. They are no longer following the horizontal manner wherein they were formed, and because of certain disturbances. So the disturbed sequence, so disturbance to the sequence, such as faulting or tilting, will be preserved in the rocks as any of the following. So for unconformities, we have 4 different descriptions. We have your angular unconformity, disconformity, non-conformity, and paraconformity. Okay, so for angular unconformity, it's very easy to identify because it's tilted strata overlain by more horizontal younger strata. So you can still see the law of superposition acting here, that the younger strata on top has formed here on top of the older strata, but you can see that it's no longer, like, the lower layer is really not horizontal anymore. Like it is now diagonal due to tectonic processes. Okay, so this type of unconformity is easy to distinguish. Okay, ayan. And then we have your disconformity. Now, disconformity shows evidence of low deposition. Alright, to proceed. So, angular unconformity, disconformity. So, disconformity shows that there was a period of time where deposition stopped. So if you can remember, deposition is the final resting place or final place of weathered sediments and before they form a rock layer. So there is a layer or a period of time there is almost no deposition, and what is present is weathering process. So in between these 2 layers, you will see that there is weathering and erosion that happened between the formation of these 2 layers. So you have a normal time where sediments are being deposited and they are forming a rock layer, but then that stopped. And the layer here on top was exposed to weathering, which resulted to this soil or regolith here in the middle. And then they formation of rock layers continued. But still, it did not follow the usual continuous deposition of materials. There was a pause, and that's important because whenever you are identifying dates and fossils, if there is a gap in your time, then you have to identify it to give a precise time period. So there was a pause, okay, before the deposition of materials and formation of rock layers continued. So this is quite easy to identify as well because you will have some evidence of erosion or weathering here in between the two rock layers. Okay. Next, you have your non-conformity. So non-conformity is present in rock layers which have two different types of rocks. So for example, you have igneous rocks which cuts into a different type of rock, different layers of rock like we seen earlier. So this is also considered as a non-conformity. So you have your normal type of rock which is cut through by either igneous or metamorphic rocks. So that's considered as here non-conformity. And for example, metamorphic rocks next to an igneous or sedimentary rocks is considered as a non-conformity. So for example here, well, usually when you are looking at rocks at the same place, it's usually the same type of rock because it's the same environment, the same weather pattern, same minerals which is present. But because of other environmental conditions that may trigger the difference in the types of rocks present. For example, here, you have a Precambrian granite, gneiss, and schist. And then the next layer, you have a Cambrian flathead sandstone. So the Precambrian is a totally different eon. So these two rock layers has been formed by different eons, which would explain why they are different types of rock. So that is because they have been formed in different eons, and those are different, very different environments in terms of the history of the earth. So this is a non-conformity. Right. Next, finally, we have your paraconformity. So paraconformity is quite difficult to identify because you don't have any clue. You don't have any clue that there was a gap in time, because in this conformity in angular unconformity you see a slant, so there was movement. In this conformity you would see evidences of weathering process. In non-conformity, well, there are two different types of rock, but paraconformity sometimes is difficult to identify because the materials may still be horizontal, it would still be normal, but in actuality, there was a gap in time. So, for example, here you have a layer which was formed 100 million annum, so 100 million years ago, and then next layer was formed 50 million years ago. So there was like a 50 million gap, but there would be very little indication otherwise. So unless you look at other relative dating methods or geologic, like absolute dating methods, then it would be difficult to tell that there's actually paraconformity present in that rock layer. Okay, so again, that was angular unconformity. Let's go back to our list. You have your angular unconformity, slanted or vertical. Disconformity, you have weathered materials. Non-conformity, different types of rocks are present. And paraconformity, difficult to identify due to the lack of evidence. Okay, so let's try if you completely identify or understand our types of unconformity. So I will show you a series of pictures and you have to identify what type of unconformity is present in the rock strata. Okay, so before you jump into conclusion, take a close look at the rock face. So you will see here on top that it's normal, it's horizontal. Okay, that's a horizontal layer. But if you look at this closely, This is actually vertical. So you can see the texture of the material is already vertical. So this is easily angular unconformity. Okay, next. Okay, so obviously, if you look at the picture, this is a cliffside near the ocean. So here's the water, here's sand, and then exposed in the sand, like, or just beyond the sand, is your angular unconformity. Okay, so this is quite easy since you have two different layers right here, and in the middle you would even see like a brownish layer here where grass is actually thriving. So you know that there is soil present in between those two layers. So this is disconformity. Okay, so that's it for our rock layers. In the next video, we will be discussing about fossils.